Good afternoon, dear students, and welcome back to our today's online class. In our previous class, we warmed up for our today's new chapter. We did a warm-up activity. Now, that warm-up activity was to get you ready for today's class, today's new chapter, and that new chapter which we are going to start is chapter 10, Work and Energy. Now in this chapter we are going to discuss about work, energy, renewable energy and non-renewable energy, different sources of energy, as well as various forms of energy one by one. So let us start our today's class, work and energy. Before knowing what is work, let us quickly revise what we have learned about force. Force is either a push, pull, or twist on an object applied by us or machines. So it can be a pull, it can be a push also, or it can be a twist or turn. So all this type of activity, push, pull, twist or turn, are known as force. We revise this force because without force this new chapter is not possible. So let us now start with work. In science, work is said to be done when the force applied. Remember, force can be pull, it can be push, or it can be twist or turn. So in science, work is said to be done when the force applied on a body moves the body in the direction of the force applied. So in order to do work, what we have to apply? We have to apply force. And that applied force must move the body in the direction of the force applied. So in short, we can define work as work is the displacement. Displacement means movement or move the body. Work is the displacement of an object due to force applied on it. So work is basically said to be done whenever an object on which we apply force moves or makes displacement. Now, like any other thing, like weight are measured by grams and kilograms. So grams and kilograms are unit. In the same way, volumes are measured in centimeter cube, liter, milliliter, etc. In the same way, work also needs to be measured, and it also has its own unit. The unit for calculating work is joule, and this joule unit is named after the inventor, famous inventor James P. Joule. So what is the unit for calculating work? Joule. Now let us see what are the conditions required for the work to be done. The first condition is there must be constant force. Without force, there will not be any work. So the first thing is we have to apply a constant force, and that force can be either push or pull or even twist and turn. The second condition is the object on which we are applying force must move over a distance. That means there must be a displacement of the object. It must change its position. Third condition is the force and the direction of the movement must be in the same direction. That means if you are applying force in the forward direction, the object also must move in the forward direction. if you are applying force in the backward direction, then the object also move in the backward direction. Let us try to see with example. Say suppose you are pushing, you want to close the book and you are pushing the book. So here, which force are you applying? Push force. In what direction? From here to here. So what should be the direction or the movement of the book? It has to move in the same direction as the direction of the force applied. So when the force is applied, push force is applied, the book closes in this way. So this part has moved to here, and what we see as a result, the book is closed. Now in the same way, if you want to open the book, so you have to apply pull force over here. So when you apply pull force, the direction of force is this side. Therefore, what will be the result? The book gets opened and this part moves this side and it gets opened like this. In this case, we can say that work is done because there is force applied, the object is moving, and the movement, direction of the movement of object is same as the direction of the force applied. So these are the three conditions for the work to be done. Now let us see some examples of work done from our daily lives. Boy pushing a cart full of coal. So the boy is pushing the cart in this direction, and in order to do work, the cart must also move in the same direction. Then only we can say that the boy is doing work. Let's see another example. Your mother goes to shopping mall and chooses one cart, puts her items which she had purchased in the cart and pushes it. So which force is she applying? Push force. In which direction? From here to here. Therefore the cart has to move from this place to this place. Then only your mother is doing work by pushing the cart. Let's see another example. A boy pulling his toy. So which force is the boy applying? It's a pull force, and the direction of force is from here to here. So the object or the toy must move in the same direction. Then only boy is doing work. Let us see another example. Say suppose there is a tug of war going on between team A and team B. Let's say team A is Goethals, represented by blue color. Now both the teams, as soon as the whistle blows, both the team applies force, and here both the team will apply pull force. So they will apply pull force in the respective direction. So team A, Goethals, will apply pull force in this direction, whereas team B will apply pull force in this direction. Now they want to do work. They want to win this game by doing work. Now work done or the winning will depend on whose pull force is greater. Now say suppose pull force of team A, Goethals, is more than the pull force of team B. So what will happen? This team B will now start moving towards team A, towards the direction of the pull force applied by team A, and the result will be team A will win. So we say that in science work is done only by team A and not by team B. Although team B was also applying force, but they were not making Goethals to move towards them. Which schoolmate, which teammate to move towards themselves. It was team A made team B to move towards itself, towards the direction of their force. Hence, team A does work and wins the tug of game. Now let us see another example from sports. Let's take my famous sports person, footballer Messi. So he is famous for free kicks. Now let us see, he wants to score a goal by taking a free kick. Let's see whether he can score a goal or not. So he is now about to kick the ball, which is there in its dead position on the ground, and there is a bar of players in front of the ball and the post, between ball and the post. Now he moves, he pulls his leg back, and now he is about to apply force. That means he is applying push force. Now he pulls the leg, but with that pull leg, now he wants to apply push force to the ball so that the ball moves in the forward direction. Now let's see what happens. Now he kicks the ball. So he has already applied push force, so the ball is moving towards the direction of the force. It is now about to cross the bar, and finally we can see that the goalkeeper is not able to save the ball. The ball has now entered inside the goal post, and hence the ball from the ground in front, which was in front of the bar, has now moved inside the goal post. That means the ball has moved from one place to another with the force applied by Messi. So what will be the end result now? Now Messi has scored a goal and he starts cheering, and therefore we can say in science, work has done, and the commenter will say goal. Correct? So let us see some examples, some more examples. What about work done in the following cases? A man is lifting a box and he is walking. So can we say that there is a work done over here? Now let us see first man lifting the box. So man is lifting the box and he is applying, to lift the box, he is applying force in the upward direction. He is applying the force in the upward direction. So therefore when he picks the box from the ground by applying upward direction pull force, at that time the box has moved from ground to the air. So here we can say work is done because there is force applied, the box is moving its place in the direction of the force. So here work is done. But let's see what happens when the man, after lifting the box, tries to walk in the forward direction, moves in the forward direction. Now at this time, let us consider the direction of force applied. The man is applying force in the forward direction over here, but the weight or the box is, the direction of box is in the upward direction. So in this case, when the man lifts the box and walks in either direction, the direction of the movement of box does not match with the direction of the force applied. Therefore, when the man lifts the box and walks, he is not doing work according to science. Why? Because the direction of the force applied and the direction of the movement is not same, although there is force being applied. Am I clear, boys? Let us see some more examples and try to figure out whether work is done or not. What about a boy pushing wall? He is putting his all energy to push the wall. The movement, the direction of force is towards this side. Will the wall move in the same direction? No, the wall will not move. Therefore, There is no displacement, so there is no work done. The boy is only wasting energy. What about you studying or reading a story book? Are you doing work? No, you are not doing work. According to science, you are not doing work. Although you are doing your mental work, you are putting your energy, you are thinking, you want to remember the words written over there, you are doing your mental work, but you are not doing physical work according to science. Let's see why. Because here when you read, you do not apply force. So when there is no force applied, no work is done. Let us see another example. Doing push-ups. When we do push-ups, we get tired. Our muscles will be stronger. But do you think that we are doing work over there? Now, every time when the man does push-up, he changes his position from ground to the air in this way, from position 1 to position 2. And he is also applying force. But at the end, this man will again come back to the same position. So after 1, he reaches 2, and again he will go back to 1. So let us see what happens. So he is applying force. There is no doubt that he is not applying force. He is applying force. But is there any displacement? Is that man moving from one place to another? No, there is no displacement. He starts from position 1, he reaches position 2, again he comes back to position 1 to continue his push-ups. Therefore, there is no displacement. Therefore, can this push-up be called work done? No, there is no work done. So when a man or woman does push-ups, although he is applying force, he is not doing any work. Only his muscles becomes stronger, but he is not doing work according to science. Therefore, what we can conclude now, work is the displacement of an object due to the force applied on it. Remember 3 important things. Work is the displacement. There has to be movement, change of position. Of what? Of an object. By what? By force applied on it. I hope I have made you clear about work. Now, based on today's class, there is an assignment for you. There are questions over here. Question number 1, define work. Please make correction, boys. Define work. Question number 1, define work. Question number 2, what are the conditions for work to happen? You have to write down the conditions required for work to happen. Question number 3, from the given activities, list out in which case work is done and work is not done. Kicking a football, reading a storybook, pushing the wall, lifting a weight, pulling a cart, singing, and finally walking inside the classroom by carrying a book over our head and opening the door. Finally, question number 4, what is the unit of work? So this much for today, boys. In our next class, we are going to discuss about energy and the relation between work and energy. Till we meet next time in our online class, stay safe and do all things well. Bye-bye.